All right. Okay, so today we're going to learn about Taylor and Maclaurin series, which is 11.10. Ideas. All right, so it is important to know, okay, these series are very common on the AP test. They usually have a whole FRQ on these. Okay, but it's important to understand, though, that these series are power series. So first, let's just remember power series. We know that it's n equal to 0 to infinity, Cn x minus a to the n, or we've got this guy, n equal to 0, infinity, Cn x to the n. Either one. Okay? This one here is centered at x equal to a, about x equal to a, at x equal to a. That's how we would say that. Here, since there is no x minus a, then our a must have been 0. Right? Okay. And so this right here is just the unique coefficient for each term. So if I were to expand this one, it would be equal to C naught plus C1 x minus a to the first plus C2 x minus a to the second plus C3 x minus a to the third, dot, 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 on forever and ever. Okay? All right, so each one of these terms has its own unique coefficient, whatever our coefficient formula is. Okay, so now enter in Taylor series. Taylor series. Okay, Taylor series is a power series where the coefficient, I'm going to write over here, Cn, is equal to this formula. It's the nth derivative. That'll be my nth derivative. Evaluated at a. Divided by n factorial. So this is my formula for each of my coefficients. So the Taylor series is this. The nth derivative evaluated at a, I put parentheses there because that will denote that it's derivative and not a power, divided by n factorial, times the quantity x minus a to the n power. This is the Taylor series. So what does the expansion look like? Well, starting off at 0, when I put 0 in here, that means I have not taken the derivative. So it is just f of a. That is my first term, right? The next term will be my first derivative evaluated at a, divided by, divided by 1 factorial, which we know is 1, times x minus a to the first power, plus f double prime evaluated at a, x minus a to the second power, divided by 2 factorial. All right, 2 factorial. I'll say just 2, but it's 2 factorial because it simplifies to that. Okay? And we don't need that there. Plus f triple prime evaluated at a, divided by 3 factorial, x minus a cubed, plus on and 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 on. Do not forget that we're doing factorial. I'll write it down here. Factorial, so on and so forth. Okay, that is what the Taylor series is. And this is called the Taylor series expansion. Okay? Now, if I want to find the radius of convergence or anything like that, I would want to do the ratio test to do the radius of convergence. And to do the interval of convergence. This is where we want to use the ratio test. Okay. And from what we learned about power series, we already know that for sure that this will converge when x is actually equal to a, because that quantity is going to go to 0. Okay, so there is the Taylor series, and then there is also the Maclaurin series, which I think of as like the baby version of the Taylor series. The Maclaurin series is an offshoot of the Taylor series. This is the Maclaurin series. It's a lot prettier. And equal to 0 to infinity. Same type of coefficient. So the nth derivative evaluated now, this time at 0 and factorial. So what is the, actually I'm right, there's x to the n. So what is the difference? Taylor series is centered at x equal to a, or about x equal to a, everything that we've talked about before. And this one is centered at x equal to 0. So the Maclaurin series is exactly the same as the Taylor series. I could call this a Taylor series centered at x equal to 0. That's what it is. So when I do the expansion, what does the expansion look like? It is going to be f of 0 plus f prime of 0, x to the first power, divided by 1 factorial, plus f double prime of 0, x to the second power, divided by 2 factorial, plus f triple prime of 0, x cubed, divided by 3 factorial, plus, and so on and so forth. Okay, that is the Taylor series, and that is the Maclaurin series. And then you can use the radius of convergence. You can use a ratio test to find the radius of convergence. Okay? All right, let's stop there.